Day 225 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 225 and we're doing question 146 LRU cache. The difficulty level is medium, but don't worry, we're going to keep the solution. It's simple and easy to understand, so let's get into it. The question says, design a data structure that follows the constraints of a least recently used cache. Implement the least recently used cache class. The LRU cache inits the capacity. Initialize the LRU cache with a positive size integer. Then it says int get int key. Return the value of the key if the key exists. Otherwise, return -1. Then it says void put int key int value. Update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The function getInput must each run on big O of 1 average time complexity. All right, y'all. So let's break that down. Let's look at this example, right? So first thing in the example, we have the input. Oh, hold on. Let me do this so we can walk through it, right? So we put this, we put the capacity up here. We just put cap for capacity, put the input, boom. Then we put the output, boom. Then we could put this would be the cache right here, right? So we put the cache, that can be the cache. Boom. Let's put some colons right here as well. Why not? Why not? Okay. Now let's look and see how we're going to do this. First thing we're going to do is we are going to initialize the capacity, right? With the capacity is 2, so we're just going to set 2 as the capacity. Then what we are going to do is we're going to call put, and what that is going to do is going to put this 1 and 1 value key pair into the cache. So let's put that into the cache, right? Boom, 1, comma 1. Let's put the input as well, so we can we just copy and paste so we can keep track as we move along. Put the input right here, and then that's going to be null. We put null like that. Boom. Put a comma. Boom. Right. So that return that when we put that, that's going to be a null because it's a put. Then we are also going to put next. We're going to put the 2-2, right? Because 2-2 comes next. So we're going to put the 2-2, add the 2-2 to the cache. Boom, just like that. We could put that right here so we could keep track, and we could put null right here so we know it returns null. Boom. Then what comes after that? After that, called to put, now we have to get 1, right? So we're going to get 1. Excuse me, this 1. We're going to get 1. Now remember, this is the get calls return the value of the key. That's why it's just 1, 1, because we just want to return the value of the key 1. So this is the key 1, the value is 1. So that's why we're going to put 1. We could just put G1 for get 1, and then the output would be 1 because we got it from the cache, right? The cache has the key value pair, key, we get the value 1, so we're just going to return the 1. Boom. Then after that, after we call get, now we're putting the 3-3. Since we're putting the 3-3, right? So we put the 3-3. Let me see. Excuse me, 3, 3. Since we put the 3-3, we are going to, the output is going to be -1, right? The output is -1 because remember the capacity is 2 and we need to evict the last recently used key, right? So we use this 1, we haven't used the 2 yet. So the last recently used one would be this 2. So we can replace this, we can replace this 2-2 with the 3-3 because remember the capacity is 2. We can only have 2 key value pairs in here at one time, right? And since since we put 3-3, boom. So actually, no, this one would be -1. We're not there yet. This is still no. So we put the 3-3. That moves, evicts the 2-2, and now we return null, right? So yeah, it goes 1. Excuse me, it goes 1, then null, 1, then null. That's right. Now, after we put the 3-3, now we get the 2. Now we get the 2. As you can see, we just removed the 2. So that's why we can put -1 right here. So we could put the G just for get 2, and then we return -1 because we removed the 2. It's not in there, so we just put the 3 in there and replace the 2, so we could just return -1. So we got the 2. Now we're gonna put 4. Boom. So we put the 4 up here. Boom. When we put the 4, that's gonna be a null because we're just putting it in there. So we put the null. Boom. Put the comma, and this 4 is going to replace this 1 because we used the 3 more recently than we used the 1. So we could just put 4. Now we have the 4 in there and the 3 in there, right? Then after that we call get 1, but we just removed the 1. We only had the 4 and the 3. I mean the 4 and the 3 in there. So we're gonna put a -1 for the output. Come up here and what it say get? Well, we supposed to get 3. Supposed to, excuse me. Let's see. That's why we gotta keep track of this stuff. We supposed to, we're supposed to get 1. So we're supposed to get 1, but it's not in there anymore. So we're just gonna keep it like this. We're gonna return the -1 because we just removed the 1, so it's not in there. Only thing in there is the 4 and the 3. Then we're gonna call get 3. The 3 is in there. So now we call get 3. The 3 is in there, so we can return the 3. And then we call get 4. The 3 is right here. Then we call get 4. The 4 is right here, so we can return the 4, right? So that's how the question works. I hope that made sense. I know it's a lot to take in. It's a lot of confusion. And that's why I tried to write it out for y'all so you don't have to do it in your head, but that's how it works. The capacity is 2. If we put something in, we have to evict the last used key value pair and replace it with the key value pair that it told us to put in. So now that makes sense, I hope that makes sense. If it does, just don't be afraid to look over it, go back and rewind the video and go through it again. But that's how it works, and I hope it'll make sense to you eventually. But now that we are done with that, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check the link out in the description. Then go ahead and like, comment, and subscribe. And then after you do that, get ready for the part that you've all been waiting for, the part that we all know and love, the actual code. And now when we get into the code, the first thing we are going to do is we are going to have to create a node class. And in order to do that, we're going to come outside of this class, create a whole new class, and we're just going to call that node. We have to call that node. Then we're going to declare a variable called key. That's going to be an integer. Then that's going to represent the key of the nodes. Then we're going to declare another variable called val. That's going to be an integer of the nodes, right? I mean, a value of the nodes. Then we have to declare another variable called prev. That is going to be a node, question mark, and that's going to reference the previous node in the double linked list. Then we have to declare another variable called next, and that's going to represent the next node in the double linked list that we are going to create. So we're going to say next node, question mark. Then we're going to come down here. We have to initialize everything. So we're going to say, or we just have to initialize the key and the value. So in order to do that, we're going to say init underscore key colon int comma underscore val colon int. Come outside of that, open up the brackets. We're going to say self.key equals key. Then we're going to say self.val equals val. Now, we're not done yet because we still, after that, we have to create a helper function that we are going to use to create when we write these functions, right? So our helper function, we're just going to come down here. We're going to say func. We'll call this move to head. Then that's going to have underscore node colon, and that's going to be a node that we just created in this class. Then we're going to come outside of that, open up the brackets, and what we're going to do is we're going to say if node equal equal sign should be 3 equal signs equals head. What we're going to do, open up the brackets, we're just going to return. But we're going to say else, open up the brackets. This is how we are going to, so this right here, if the node is already at the head, we're going to do nothing. But now we're going to say else, we're going to say node dot prev question mark dot next equals node dot next. Then we're going to come underneath this and we're going to say node dot next question mark dot prev, excuse me, is going to equal node dot prev, just like that. And what that's going to do, those two things are going to remove the node from its current position. Now we have to move the node to its head. In order to do that, we're going to say node dot next equals head. Then we're going to come down here, we're going to say head question mark dot prev, excuse me, that should be prev equals node, and we're going to come underneath that and we're going to say head equals node. Boom, just like so. Now that's our helper function, or not yet, sorry, not yet, y'all, because we have to handle a situation where if the node was the tail, we have to update the tail reference, right? So in order to do that, we're going to just come down here, we're going to say if node 3 equal signs equals the tail. This time what we're going to do is we're going to say tail equals tail question mark dot next. Then we're going to come down, oh excuse me, tail question mark dot prev, sorry about that, y'all. Then we're going to come down here and we're going to say tail question mark dot next equals nil, just like that. Now that's our helper function. Now that we've done that, let's get into this actual LRU cache class that they have already prepared for us. And the first thing we are going to do with that is we are going to declare a variable, which is going to be a dictionary to store the key value pairs where the value, first thing we're going to do is we're going to declare, come outside of this, declare a variable called cache, and that is going to be the dictionary to store the key value pairs. So we're going to say var cache, open up the array bracket, square brackets, we're going to say int colon node. That's going to be cast that as a blank dictionary like that, and that's going to be where we store the dictionary, the key value pairs in our dictionary, right? Then we're going to come down here, we're going to declare a variable called count, and that is going to be an integer, and we're going to set that at 0 to start, and that's going to keep track of the current number of elements in the cache, right? Because remember, the capacity only allows us a certain amount of elements, and that's going to help us to keep count of those. Then we're going to declare a constant called capacity. Excuse me, capacity, and we are going to make that's going to be an integer. Then we are going to need to reference the head and the tail, so we're going to declare a variable called head, and that's just going to be a node question mark, and another variable called tail, and that's going to be a node as well, node question mark, just like that. Now we come down here into the init. We need to initialize the capacity, so all we're going to do is say self.capacity equals capacity, which we just created up here, or no, well, that's coming from right here, right? Then we're going to come down here and we are going to say, oh no, it's time to get into the get function, right? So for the get function, we're just going to say if let node equals cache, open up the square brackets key. Then what we are going to do is, first we're going to come out here, we're going to open up the brackets, we are going to say move to head. We're going to call that helper function that we just created node, excuse me, parentheses node. Then we're going to come down here and we are going to say return node.val. Then we're just going to come down here in case it doesn't exist, And if it doesn't exist, we're just going to say return -1, just like that. Boom. Now we have to get into the put function. Put function is a little longer, but we'll get through it. For the put function, what we are going to do is we are going to say, we're going to say if let node equals cache square bracket key. What we are going to do, come outside that, open up the brackets. We are going to say node.val equals value, which comes from right here. Then we are going to say move to head, open up the parentheses, node, just like so. Then now we have to do the else. And for the else, what we are going to do, we're going to say, if the key does not exist, we need to create a new node. So we're going to say let node equal node, open up the, node, open up the parentheses, key, comma, value. Then we're going to come underneath that and insert the new node into the doubly linked list. So in order to do that, we're going to say node.next equals head. Then we're going to come underneath that. We're going to say head question mark dot prev equals node. Then we're going to come underneath that. We are going to say head equals node. Come underneath that. We're going to say cache square bracket key equals node. And then we're going to increment count by saying count plus equals 1. We're not done yet. We're getting there though. We need to come underneath this right here. And we are going to say if, oh, excuse me. Well, not yet. Come underneath the count. First, we're going to say if tail is equal to equal sign nil, what we are going to do is set the tail equal to the head. Boom. Now we're going to come down here underneath this and we're going to say if count is greater than capacity, because remember the capacity is, we're only allowing enough key value pairs up to the capacity. So, and each time we add a key value pair, we're going to increment it by 1. So if count goes above the capacity, that means we need to evict a key value pair. In order to do that, we're going to say cache dot remove value, open up parentheses, for key colon tail exclamation point key. And we're going to come underneath that. We're going to say tail equals tail, question mark dot prev. Come underneath that. We're going to say tail question mark dot next equals nil. Come underneath that. We're going to say count minus equals 1. So we're going to decrement the count to let it know that we just removed a key value pair so we could get back to the capacity that we're supposed to be at. Now, that should be all she wrote. I know that's a lot of code, y'all, so let's run it. Make sure it runs how it's supposed to run. Let's see. Okay. So let's see where the error is. Oh, excuse me. Shouldn't be any white space after that. Should be question mark dot next. Let's run it again. Run it again. Okay, what does it say? Oh, sorry, y'all. Minus equal space 1, not all together. Another white space issue. Let's see. And it's accepted, y'all. So let's submit it. See what happens after we submit it. Let's see. Okay, 86 milliseconds beats 87.91% of users with Swift, y'all. Not too bad at all. I hope y'all learned something today, and I hope to see y'all here for another day, another LeetCode problem. Before we leave, though, y'all, get one more look at the code. I know it's a lot. So let's go look at the put function. The put function is pretty long, so get one more look at it. Here's the rest of the put function and some of the move the head function. Get that, get that. So here's the move the head function. Boom. And now look, this is the node class that we created as well, y'all. So I hope y'all learned something. Hope to see y'all here tomorrow. I'll be here, as you know, we're doing LeetCode problems every day. I'll see y'all then.